So we've got some example calculations, z-scores, and then some questions about finding a z-score and then looking it up in the tables and quoting an answer. And here we go. So here's how you compute z for these values. Remember, z is x minus mu over sigma. So you're going to type it in your calculator. You're going to put parentheses 23 minus 10 divided by 2.5, like that. Happen to have it here, parentheses, 23 minus 10, close it, divided by 2.5, 5.2. And we can think about where that would appear in the distribution. If you just draw it, you know that everything reasonable happens from minus 3 to 3. So 5.2 is out here somewhere. Not likely to be way out there. Okay. Here, x is 3. You're going to x minus mu over sigma with this, so that'd be 3 minus 8 over 5. Try it out. 3 minus 8 divided by 5. It says minus 1. Oh, that's negative 1. It is, too. And here's some crazy stuff here. X is 0.15 minus a minus 0.09 divided by 0.11. So either you change this to a plus sign, or you go minus, then you use the little, this is a subtract sign. That's the negative number sign. You can type it in that way. I will. Parentheses, 0.15 minus a negative 0.09, close it up, divided by 0.11. And I get 2.1818 repeating like that. And you get the same answer if you did parentheses 0.15 plus 0.09 divided by 0.11. If you typed it right. 15 plus 0.09 divided by 0.11. True enough, okay. So that's finding z-score. So now we know what to do with these z-scores once we get them using the tables. We know how to compute z-scores from data and mean and standard deviation. Now we're going to combine those operations to answer these two questions. Suppose the population is normal with mean 100, and sigma is 12. Find the proportion below 12. 12? Find the proportion, 90 it says. I just copied it wrong. Okay, 90. 12 would be a bad answer. Okay, below 90. You see 12, you write 12. I guess that can happen. The body just takes over the mind. Or maybe the mind is taking over the body. So I'm going to compute a z value. Z is x minus mu over sigma. X is 90 minus 100 over 12. And so I do parentheses 90 minus 100, close it, divided by 12. Minus 0.833, like that. So then I go to the tables. Z is minus 0.83. I can only use two places. The area, okay, so minus, it's minus. I'm on the minus side. 0.83 here. It looks like a 2033. Is the proportion of the population below x equals 90. And then the second question is, suppose the population has that same distribution, find the probability and observation is below 90. Well, the proportion and probability, it's the same calculation, same answer. So probability and observation is below 90 is also 0.2033. Okay, so I took care of that. So the proportion below and the probability are the same number. In fact, the proportion of the population satisfying some condition and the probability of finding an observation satisfying the same condition, they're the same number. That kind of makes sense because that's the fraction of the population, so that's the chance you might choose that kind of value randomly out of the population. And we're moving on to the next slide.